How does the agent custody assets?
Each off-chain agent has effectively an EOA, which is registered on an on-chain smart account. There is a threshold which needs to be met in terms of signatures for any action to be taken on that smart account.
How does the protocol interact with the tech stack? What is the tech stack?
The tech stack basically is like a framework to build agents. So you can have, let's say, a group of people, a DAO for instance, run one node each, one agent each, and then the collection of them makes up the entirety of the agent.
Welcome to the Bare Metal Podcast.
Hey everyone, this is Shiptico from Rockaway.x at the Bare Metal Podcast. Thanks for tuning back in. Today I've got here with me David from Valory.xyz. Welcome, David.
Hey, thanks for having me.
So, can you give us a short intro to yourself and you know what sort of a project Valory is?
Yeah, sure. So I'm David, CEO of Valory and co-founder as well. Valory itself has this mission to effectively, ultimately give everyone an autonomous AI agent, an AI system that they can own fully without any compromises. And today we basically very focused on realizing that via the OLAS protocol, which is basically a protocol to coordinate multi-agent use cases and generate entire economies of these sort of autonomous AI agents. And we can dive into sort of what we mean by that.
Yeah, I'd like to dive into that soonest. I'm curious, why do you think the time for agents is now?
Yeah, that's a great question. So I've actually been building autonomous agents for some time, for over 5 years. And initially, I thought the big unlock was sort of smart contract blockchains, because what they enable agents to do is sort of permissionlessly transact, permissionlessly, create complex contracts the same way humans can. And actually, I would argue that blockchains more generally, crypto more generally, is actually first built for machines and second for humans. So it's a natural kind of interface to place an agent between a human and the blockchain because it's a complex thing to interact with. We see this today, ultimately it's quite hard to onboard people into crypto because it's complex. But actually I was wrong. So it turns out you need more than just smart contract blockchains. What you also need is much more capable agent systems. And this unlock really kind of happened a year or 1.5 ago with the arrival of really capable large language models. Because what that has done is has taken sort of these kind of rule-based systems to systems that are sort of more open-ended. So you can now build quite sophisticated autonomous AI agents that utilize these large language models and are much more powerful than what you would have been able to do 2 years ago, let's say. And so that has allowed a large number of novel use cases which were just not feasible or tractable back then.
Super interested in what those agents do, but I think it'd be great to sort of dive into how the whole ecosystem works. So could you give us a 10,000-foot overview, talk about the OLAS protocol, and there is the OLAS tech stack. Just give us the lay of the land. How does the protocol interact with the tech stack? What is the tech stack? So we can sort of take it piece by piece.
Yeah, let's do it. So the tech stack basically is like a framework to build agents. There's quite a few frameworks to build agents. In the Web2 world, there's things like LangChain, AutoGPT. We've built one which is very crypto native. So it incorporates account abstraction at the core. It also allows you to create agents initially as sovereign agent, as we call them, or single agents, where they might run on your computer or in the cloud as a centralized instance and interact with the chain. But then you can take the same code base and you can create a distributed and decentralized system out of it. So you can have, let's say, a group of people, a DAO, for instance, run one node each, one agent each, and then the collection of them makes up the entirety of the agent. And so if, not all operators are running their agents, then the system wouldn't work. So this is actually quite interesting as a use case in and of itself. But kind of to stick to the topic first, that's the framework. So it allows you to build these sovereign or decentralized agents. and the framework does not have an opinion as to what that agent does. It can do quite a lot of different things, and we'll, I'm sure, cover that. On the other hand, you have the protocol. So the protocol is deployed currently on 8 blockchains, like 7 EVM chains and Solana, and we're kind of adding more as time passes. What the protocol does is a couple of things. So it coordinates these off-chain entities. So if there's a single agent, a sovereign agent, it mostly provides like the account abstraction and some various like kind of management functionalities. If you're thinking about the decentralized agent, it also has to coordinate basically these different off-chain entities and sort of make sure that when they sign transaction that this is all correct and so on. Another role of the protocol is the whole sort of token aspect of it. Like there's a utility token in it called OLAS as well. And that has like multiple roles, like ultimately coordinates the entire ecosystem. In the ecosystem, if you go to the site olas.network, you'll find that there's these 6 roles. Like one core role is a builder. So the protocol has this dev rewards mechanism for builders to permission their own basically rewards for contributing code into the ecosystem. Another key role is the operator. So those are the people running the agents. There's a whole staking mechanism which kind of incentivizes those, again, part of the protocol. And so you can kind of go through the roles, and they're kind of all having a mechanism which kind of allows them to contribute into the ecosystem. Because ultimately, OLAS, the stack in this protocol, as an aim, has to grow basically autonomous AI agent economies. Why does that matter? Because ultimately, we need to be realistic. If we want to build autonomous AI agents that are as powerful and as useful, ultimately to end users as they can be, we need to create like massive flywheels, also including data, to basically build better and better agents and kind of slowly wean ourselves off like centralized components like OpenAI. And so this is a lot about bootstrapping more and more autonomous AI agents that interact and allow us to become like a healthy ecosystem of autonomous AI agents and autonomous AI agent infrastructure.
That's a lot of moving pieces, so very interested in digging deeper on this. One question I wanted to ask, like how does the, if we go back to the agent tech stack, start with that, how does in the distributed sort of world, how does the agent custody assets, or does it custody any assets? Is the agent connected to a smart contract, or does it have its own account, and then how's that account protected across those distributed nodes? That's always a point of interest with agents.
Yeah. So in the case of the decentralized agent, where we basically have a distributed off-chain system, what happens is that each off-chain agent has effectively an EOA, which is registered on an on-chain smart account. Like currently on EVM, we tend to default to Safe, and on Solana to Squads. And basically, they're a signer in this multisig. And what then happens is that there's a threshold which needs to be met in terms of signatures for any action to be taken on that smart account. And that threshold is identical to the threshold for the consensus. So specifically, the underlying consensus mechanism is a Byzantine fault tolerant like Tendermint basically instance, like a modded one, whereby 2/3 or more of the agents have to be live and in agreement at any given time. And so if you put those two things together, you have this off-chain system. In the most simple case, it's like an oracle. It pulls in some information, it agrees off-chain on this information. 2/3 or more of the agents agree, they sign that message, and then it can only then it can settle on-chain, because on-chain you have that sort of verification. Now, if you go beyond that complexity, let's say you have like an element where you have an autonomous fund, right? Autonomous fund manager. So this off-chain system acts a bit like an oracle. Maybe it creates an index, and then it uses that index to adjust its on-chain portfolio. Then again, you could do the same thing where basically there's this aggregation off-chain, they agree, but then furthermore on-chain, you can introduce additional constraints. So for instance, The safe kind of natively offers this, where you have these guards, which you can add to the safe,
Right.
which
Squads of
allows you to
approvers.
basically,
Right.
yeah, well, or just restrict the parameter and action space of the agent. So you can upfront restrict what, like even like methods on other smart contracts you can even call, and so on. So
Which you
that's
can't do
up
with
to the use
squads like at
case.
the moment, right? Yeah. So on
Sorry?
squads you'd have to have, which you can't do on squads at the moment, right? You'd have to have these approval roles that
Solana is,
they
yeah,
have to
way more
choose.
involved. Yeah, unfortunately, yeah. It's a very different account model as well. Yeah.
Right. Super interesting. So in constructive agent, my second question was where do the LLMs run? Because that's the very big computational role. So first of all, it's clear that in operating the agent, you have it's a clear distributed computation model, which then whenever there's an action to be taken, there's a vote taken, as you've explained. That makes sense. How do you guys run those workload? LLM workloads are some of the highest computational workloads we have today that are very widely distributed. So who foots the bill to run these LLMs to move those agents forward in state and time?
Well, the last part is easily answered. The agent foots the bill, so any use case pays for its own usage. But the question is, where do they run? So, like the stack is like agnostic to this. It depends on the use case. So, we have everything from like using centralized OpenAI's API to like more decentralized systems, like plugging into the BitTensor network, plugging into like locally hosted large language model to the degree that they're useful. So it really again depends on the use case. And one thing which is quite interesting here is that by design, large language models are not deterministic. So what you tend to get is an oracle problem anyway. So that also has actually there's a nice pro to that problem in a way. So let's go to a use case to make it concrete. We have this governator, which is basically a use case whereby an autonomous AI agent built on the OLA stack runs in this decentralized fashion. And what does this agent do? Well, you and I can delegate our tokens to it. When we do so, it will now have voting power for said token, and it will start watching for proposals on chain and on Snapshot, which arise for that token. When a proposal comes along, it will then take that and the assigned basically voting preferences. So when you and I delegated, we also assign our voting preferences. And now the system, the agent will basically take these preferences, take the proposal, and feed this to a large language model via prompt, basically. Now, you can imagine that if you were to run this as a single agent, there's a whole bunch of concerns you could have. Like, firstly, I can modify the code and never actually do what the code says, but just sign it to say no or yes all the time or whatever. The other issue is that even if I honestly operate the system, the large language models are not perfect. So they have what's called these hallucinations. They also might explicitly be poisoned in a certain part of the parameter space. So that's unlikely to be the case for this because, no one cares that much about our votes. But let's imagine this was a large DAO and somehow someone was able to previously introduce some area in the model's parameter space which gets affected specifically for this proposal. All sorts of things could happen. So what you really want is that the decision isn't resting on a single large language model. And this is actually where the system makes a lot of sense because you can think of it like an oracle. Each agent in the decentralized setup will individually call whatever large language model you want it to call. And then there's an aggregation of these vote preferences before there's any action taken.
Right, and that's where it very nicely reduces because the final vote actions come from a closed set, right? There's so vote yes, no, abstain, no with veto or something like that. So all the LLMs will somehow need to have that consistent output, which is easily aggregatable. I guess that's a great use case. And I wasn't thinking of the agents, actually the distributed agent executors, I don't know what I should call them, that are contributing to the final decision of that one, virtual agent running different large language models. That's definitely sort of like a good hedge against this like say data poisoning attack or some manipulations of the agent on the part of any individual operator. So let me ask you this: is there a dedicated operator network that runs, the protocol that contribute compute power to these agents on their own hardware, or is this mostly cloud-based? What's the status today, and what is the vision moving on?
Yeah, that's a great question. So because all these use like basically from the perspective of the OLS protocol, you can see this, there's like this registry with the services, and the service is basically this technical term for these agents. But what happens is that each service has its own configuration. So some of them have the centralized nature, some of them have this decentralized nature, some of those have like 4, 10, whatever number of agents. So it really depends on what the configurations are. So there isn't like one like unified network, more like it's like many distinct networks which are being operated. And so when you're an agent operator today, like there's different ways to get involved. So the majority of agent operators basically come through like the top of the funnel of the website. They'll see like all this network, they get involved. It says operate, you go and operate, and then like there's this basic guide to either install an app on your desktop and run it via this, or like download like this quick start, which allows you to also deploy it in like some cloud infrastructure or your local machine or whatever. So these are the targeted specifically at decentralized agents, and so they tend to run on wherever people run them, right? Whereas in the decentralized,
and so let me quickly interject because I'm curious: is this like a general runtime for agents that are constructed using the OLS tech stack? Meaning, I spin this up once, and then I can offer my computational services for her, and then many agents can come and execute, on this runtime that I've just set up. Or so how does that? Is that a fair summary, or is it per agent?
It is a general runtime, but currently it doesn't like get utilized like this. So currently you are downloading the runtime plus like a very specific agent. So there's no like dynamic assignment of like agents yet. It's just like we're too early in the bootstrapping phase for that to make sense. Like right now, basically when you're operating an agent, you're operating a very specific kind of agent. But down the line, that's certainly the intention, that basically you have like this kind of parent agent which will dynamically select within some kind of constraints which you as the operator provide the agent which it should be running. But it's basically we discussed this and it's too early.
Yeah, but totally makes sense. So in the future there will be somebody like an agent runner that will just provide some capacity. And then I as a user can say, hey, I want to run this agent, and I want at least one in Europe and at least one in the US for resilience. And then I can just set this whole thing up, and there'll be professionals who are sort of running my system.
Yeah, so that is, I mean, it's already possible, right? So we already have these kind of decentralized agents. Just requires a bit more coordination. The protocol doesn't like automatically push these into like different zones, let's say. Another point, for us, it's like very like as core contributors, we at Valory very much care about like everyone being able to run an agent. So actually, recently we launched this app called Pearl, which really lowers the barriers to entry. So previously you had to like install some Python stuff. Now you basically just install this desktop app, and then you can run an agent. And at the moment, these agents are sort of really like background workers, right? They're like specific to some use case, and then they work in this use case. And you as the user, you kind of feed them with some capital, and then you kind of benefit from running them, but you're not like interacting with them. Like there is basically an intense bootstrapping sequence to all of this, because ultimately, I think, it's a bit of a don't put the cart before the horse kind of situation. Like we didn't want to create like some sort of chat interface which is worse than ChatGPT and call that an innovation, right? Like it's intentionally about like putting autonomous AI agents into work where they work together on some use cases like prediction markets, like this governor, like other cases which we can cover. And from the end user perspective, making it as simple as possible to operate them today. And now we're like in a good spot, like people are starting to be able to operate them. Now we want to naturally scale that. And as this kind of operator network grows also via like this kind of organic means, then yes, we already have like last week or 2 weeks ago, there was like a proposal brought to the DAO to introduce a liquid staking token network on top of OLAS. So it's basically OLAS's Lido. And I think there will be this like push towards having also like very professional operators. But I think as a network, it's very important that we keep the barriers to entry basically as close to possible, as close to zero as possible. Simply because that's the mission. Like ultimately, we want to give like end user on autonomous agents, which ultimately, not today, they can give like an arbitrary goal, and this agent will sort of just more or less do it for them, right? And so
Right.
it's really important that we have this like kind of broad operator network, not just like a couple of like very specialized operators who abstract all of this for the end user.
This is where I feel the staking model goes against this, as you've correctly summarized, because it always raises the capital intensity, and then just people increase the stake until the reward is so small they're not willing to accept sort of the economic risk. But I was wondering if staking has, if it has protective functionality, meaning is that a safety guarantee in the sense that the stake is actually slashable if the agent is shown to misbehave, or what is the meaning of staking on agents?
Yeah, our staking model is called staking so that people know how to call it, not because it's very similar to other staking models. It's very, very different. So basically, at the heart of it is what we call proof of active agent. So we basically said, okay, well, what do we want to create? We want to create like these economies of agents that do useful things that ultimately benefit their owners. Why even like an economy before I answer the staking thing, right? Like implicit to this is like a deep rooted observation that basically AI systems as they scale in human society will look a lot like multi-agent systems. So a lot of discourse often like in the AI space focuses around this idea that there will be this sort of one monolithic system which potentially will even like sort of obliterate us. But when you actually dive in, you'll see that like specialization is something which starts to emerge quite quickly. I mean that all the use cases today are highly specialized by the technological constraints, but even once you lift some technological constraints, still makes sense to have like individual agents specialize in certain things due to the economies of scale, which is same as for humans. So basically, once you take this as a starting point, like there's specialization with agents, what you very quickly have is that you have like these kind of multi-agent system where one agent, in order to get something done, relies on some other agent to be present. We already have this, like in the prediction market example, there's like 4 types of agents which are interacting to even like get the whole thing done, the prediction markets. And basically every other use case we have has at least 2 agents like trading with each other to get the final output done. And so this means you need to coordinate all these agents, and it starts very much looking like running like an agent business, right? Like you have all these synthetic agents which are running around doing things, and they should be doing very specific things, and then they should be rewarded. If they don't do them, they shouldn't. So we came up with this thing called proof of active agent, which basically embeds like these activity requirements in a smart contract, and that can either be like purely on-chain activity, which can be tracked by this, or it can be like a hybrid of on-chain and off-chain, or purely off-chain, where depending on the designer, it can involve like some zero knowledge kind of technology to verify this. And so what then happens is that basically if you are running an agent, if you're an agent operator, then basically this agent has to hit its activity requirements. And once it has hit them, it will basically get its staking reward. If it does not hit them, then it goes at a risk, like currently basically it just has an opportunity cost, and it has basically a risk of being sort of what's called like black boxed, where for amount of time it can't actually earn any further staking rewards. But like the OLAP stack actually also offers slashing. Now in the single
Mhm.
agent use cases, in the sovereign agent use cases, this slashing often isn't incentive compatible, but in the decentralized agent use cases, it can be heavily deployed. So for instance, you can slash for non-availability and things like that. But at the end of the day, simply put, from an operator perspective, you download the client, it'll guide you through like setting up your agent with like the funds, and then you run it. And as long as you've kind of provided internet connectivity and funded it, it'll hit its activity requirements, and unlock its reward. And from the perspective of the protocol, then you can almost like each staking contract, which targets like a specific use case, can dial in the right number of agents to be present to get something done.
That's super interesting. So I was even in my head, I was thinking about like whether there could be sort of like a control agent, right? That would because proof of agent activity, meaning the agent has responded to a request. If I'm mapping this right in my head, right, it's not non-responsive in the sense of like blocking, additional execution. But there is no like I didn't hear about anything that would sort of restrict actions or check whether an action is valid. But this could potentially be solved by another type of agent, which could be like a control agent that would have to okay the activity, make sure it's safe, or just have like a supervisory role that you'd have to sort of send assets to for escrow. And if the agent said, this activity is likely malicious, you potentially get slashed or something like that. So I guess another agent could fulfill this sort of like economic security style role.
Yeah, so the reason, so I didn't go into the specifics because it's specific to each staking contract. So basically, OLAS provides this generic like factory element where some of those things are defined, and then like the actual like use case defines like the actual final instance of the staking contract. So I can talk to one example to make it concrete. In OLAS Predict, you have these 4 types of agents interacting. So proof of active agent basically measures that these interactions are actually taking place, and it can see this on chain. And so basically, whilst the agent can sort of interact in a fake way, it will incur cost, and so actually the agent is better off like interacting in a real way with the other agents. And this is sort of a multi-party thing where these interactions come from different sides, or tracked in different directions. And so it's quite incentive compatible for the agents to actually do what they're meant to be doing. And if they do that, they hit these activity requirements. If they don't, like if, for instance, you don't turn it on, then you don't hit those activity requirements.
I was intrigued by a phrase I saw.
But you could, I mean,
yeah, please continue.
yeah, I mean, like the coordinator thing is another. It really depends on what the designer of any given staking economy wants. What's the right thing for that as well.
Makes sense. I was very interested in this like synthetic users phrase that I saw online. I was wondering what kind of, it says, I'm interested in synthetic users for your protocol. I think all protocols sort of struggle with users, or think about distribution and how they can reach potential users, but it's usually humans. So now you're saying synthetic users. Like, what would that look like? And are you piloting this with anybody?
Yeah. So one example is a product called Baby Degen.
Baby
So
Degen?
yeah. So as the name suggests, it's a Degen in its early innings, and it's an autonomous AI agent which you delegate funds to, and it will then sort of roam free to follow portfolio strategy, like acquire various tokens, try to sort of maximize its yield. From the perspective of like the protocols which this agent engages in, it's like a synthetic user, right? So like what we mean by this is that like, and we see this actually, our BD side sees this every day. It's like protocols get very excited about this because they can see that if there's certain agent use cases built on top of them, which abstract activity for end users, that the protocol level KPIs could go much higher, and the user could have a larger benefit. Because the reality is a lot of these crypto protocols, even if they're great, still require a lot of like, conceptual overhead to even like engage with them, right? And so kind of outsourcing that to like an autonomous AI agent, it's like something people are really aware of. I mean, prediction market is just the best example because I think, just recently, or obviously Pulley market raised this large round, and we're currently in this kind of cycle where, prediction markets naturally matter, which is the election cycle. But generally speaking, like prediction markets have always struggled. And we do prediction markets fully autonomous agent based, so there is no humans involved. Like the markets get created by agents, the market get closed by agents, the trading agents are agents, and all the predictions are generated by agents. This is a very natural case where on Gnosis you can already see like they basically had no one do prediction markets like 3/4 of a year ago. Now our agents do around I think 20 to 30,000 transactions there every week, and almost exclusively in the context of these prediction markets right now. So like from the perspective of the Omen protocol, well, almost all their users are now synthetic. From the perspective of various other protocols along the stack, be it the RPC, be it the chain itself, be it Safe, the protocol, the agents currently do more than 70% of Safe transactions on Gnosis chain, right? So like the largest user base actually of Safe on Gnosis chain is currently OLAS agents. And so I think that switch is happening now for quite a few people. Yeah, because you can see that, like, I mean, really, again, I think if you think about like bringing crypto to the masses, it is not about just having a slightly slicker UI. Like that's fine, that will help the initiated and the marginal, next customer. But if you want to bring in like a 10x of users, like you need a fundamentally different experience, because ultimately even I won't engage with a lot of those protocols simply because I don't have time. So if I can outsource that to an autonomous AI agent that acts on my behalf and simply is tasked to maybe, make me a bit wealthier, make me a bit healthier, make me a bit like feeling better, right? Like these are ultimately the big aims I have. Then you can very quickly see how there are these synthetic users which abstract the actual end user and interact with these protocols.
This prediction market is interesting because at first I was thinking, the pitch then toward the protocol is removing friction for users to interact with the protocol. But here in the prediction markets, I think it's very interesting that you have now as like an additional player, like a synthetic community, which is adjusting those, which is affecting those prediction markets and playing the game, which in some sense might be, funneling new entropy into those prediction markets, new systems of non-human-like thinking that affects the odds in the market and then the trades. That's a very interesting use case, but it seems that the revolution is already starting and there'll be more agents than autonomous agents than people out there soon if you guys are successful.
Yeah, and I mean there's another, so when you're doing something like us where it's kind of really greenfield, a lot of questions are always around bootstrapping. Like you can't like put the cart in front of the horse all the time, and so prediction markets again are like a key, I think, ingredient to more intelligent autonomous AI systems, because again, like people like often default to like some sort of monolithic thinking way too quickly when it comes to AI. So they imagine this kind of centralized cluster of intelligence. The problem with this is that like the world doesn't work like this. Like if you have like an error in that model or whatever it is, well, that will now affect everything, right? And so basically prediction markets are a way to sort of minimize this, because you can source like intelligence from like a broad pool, right? Human and non-human. And so what we actually think is that these prediction markets, like specifically unlocking the long tail of prediction markets, which is exactly what we're doing, right? Like the long tail where a human would never bother involving because it's just not worth their time and effort. If you unlock that and reliably make it accessible via these markets where any given question can be answered, like basically by these markets, by the agents behind these markets, then this itself can become input to agents making more high-level decisions, right? Because what you then get is, rather than asking your model instance about like some probability of something, you can outsource that to effectively a pool of hundreds, thousands of
Get an
models,
aggregate.
aggregate that information, and make it an input to your decision making.
That might the models might actually have access and looking at different data, right? So there's additional diversification in the source of the
100%, yeah.
information. Yeah, that's super interesting.
Yeah, because
all right, so that was sounds like you guys are developing very exciting tech.
Thanks.
Well, I enjoyed our chat. I guess this is a great place to end the recording. So thanks very much for coming on, David, and best of luck to you all.
Thank you for having me. Cheers. Yeah.